In this video, we are going to take a look at the Mesh Collider. Now, Lee, what is the purpose of the Mesh Collider?
Well, the Mesh Collider is a simplified way of getting a very complex collider in place without having to go through and make a compound primitive type collider. If you've got something that is very complex like a spiral staircase, it would take you, all day just to make a compound collider out of it, where you could quite simply just use the mesh that you're using for your spiral staircase and repurpose it as a collider.
You could. I mean, and the only problem might come from that is if that particular mesh was very, very dense, in which case you may need to go and create an entirely separate mesh, something simple but doesn't really fit into the scope of a series of primitives that could define the shape of your object. In the end, a mesh collider is a custom 3D model, be it simply the one that you're already using in the mesh filter to actually display your geometry. It could be the exact same mesh. In fact, it will be here in just a moment. Or it could be an entirely separate mesh.
Something that's been greatly simplified for both efficiency and calculation, as well as making it easier to navigate the level without getting hung up on little pieces sticking out of your geometry.
That's right. So, I mean, like, for instance, you could have... Oh, I don't know. Maybe this example will be familiar to one or two of you out there, but you could have something like a spaceship, right? So here's a totally random spaceship that you've never seen before. And it could have all kinds of polygons in it. I mean, this could be like a 2,000 polygon spaceship, and you don't really want to use a 2,000 polygon object as a collision surface. In fact, you probably can't. If you were to set that to convex, Unity would just say no flat out. Now, you could create several different custom primitive, just some primitive colliders, and you could position those accordingly. Like, you could say a capsule could surround the entire body, and a capsule could surround this, and then you could use some box colliders to get these little wing sections. Or you could go into Maya or 3ds Max or whatever your 3D application happens to be, and build a very simple piece of geometry that perfectly surrounds your spaceship and had a minimal number of polygons around it, and you could use that as a custom collision surface. And that example may ring familiar to one or two of you out there, and if it did, then good on you. Now, let's jump over into Unity and let's take a look at using one of these. Now, in this case, I'm just going to take an existing mesh that we're already looking at, and I'll just repurpose that as the collider. You could use the exact same system to drop a mesh collider onto another object. We'll take a look at that too. So let me see here. If I take a look under my FBX, I've got this teardrop mesh, which I'm just going to drag into the scene. And you see, it's just a little cool-looking teardrop sort of thing. I think I modeled that in just a couple of seconds over inside of Maya. Let's go under Component and jump down to Physics, and we'll drop on a rigid body. And that'll lose the prefab, which of course is just fine. And then we'll go back underneath Component and back over to Physics, and this time we'll drop on a Mesh Collider. Now, the Mesh Collider has a couple of new properties for us. We see our classic ones. We have our material, which let's go ahead and put, say, the bouncy material on there. We have is trigger, which we already talked about. Now, we also have smooth sphere collisions. Now, Lee, what is this going to do for us?
Well, it's going to simplify the mesh the best it can to help prevent getting snagged up on things. Similar to where I was talking about, if you've got a piece of geometry that has a lot of complex shapes in it, this will try to smooth that shape out and contain it the best it can to smooth it out.
That's right. Basically, it's going to simplify things down into a smooth sphere, which just as the name suggests. Now, we're not going to be using that. Now, the next one we have is convex. Now, this one's really important, and I'll just show you why first off. So let me move this up into the air so I know we have plenty of time to see the result. And if we hit play, our teardrop just falls down through the world.
Right. There's a couple of limitations when using a sphere collider.
You mean a mesh collider?
Or, sorry, you're right. Mesh collider. My bad. The main one being that two mesh colliders are not going to interact with each other unless you tell them to.
That's right. Two mesh colliders will not collide, and there's always an exception, right? Unless we use convex. And convex is a checkbox you just saw on the properties earlier on. So let's go back over into Unity, and we'll check convex and hit play. And now as soon as we do that, we bounce off the ground.
Right. Which means, obviously, our terrain has to be a mesh collider or
That's
some
right.
sort.
Now,
But it's a special type.
well, our terrain, if we were to select the terrain, you'll see that it actually has a terrain collider on it. And again, yeah, that's going to be a special case specifically for terrains, but it's being calculated similarly to a mesh collider. Now, there's a second limitation with mesh colliders when you're using the convex property. And what is that?
There is a limit that you can only use up to 255 triangles on your mesh.
Not polygons, but triangles. Please keep that in mind, because a polygon can have any number of sides, and it's not quads, because a quad is actually 2 triangles. So always remember 255 triangles, and that is it if you plan to use convex. Now, fortunately, my little mesh here was very, very simple, and so this is working out very well for us. But you can see that by switching this on, we can now bounce based on the actual shape. So you see we hit that point, and the point bounces back up into the air.
Oh, but it didn't burst into flames.
No, it didn't. But we're able to roll around based on that edge. And it would be, you could say this is kind of like, the ideal collision, but it does come at a greater cost.
Right. The more, in a mesh collider, what it's doing is it's determining based on the vertices that are in that object and looking for collisions inside of that volume. The more vertices you have, the more costly that calculation is going to be, which is why with convex, if you've got multiple meshes coming to collide, there's a limitation on the number of checks it's willing to do.
That's right. Now, just for the fun of it, let's just turn on smooth sphere collisions, and we'll just take a look at the behavior. And you'll notice we're still kind of bouncing off of that end, but this would be a much more important calculation. It almost looked like it lit on fire for just a second there. This would be a lot more important if we had something like an underwater mine or something that was very spiky that had a lot of extrusions going out in different locations. It would simplify the overall result of the mesh to something a little bit more useful. Now, the last property we have in the list is mesh, and this is a reference to exactly what mesh we're using. Now, notice that by default, it grabbed the same mesh that has already been placed into our mesh filter. So you see that here. They're both referencing the exact same mesh, but the cool thing about that property is that we can use it on anything. So let's say we go, let me go create a box, or a cube, if you will. Now, I'm going to remove its box collider. Then we'll go under Component, jump over to Physics, and we'll drop on a Mesh Collider. And I just want to point this out. See, now we're using a Mesh Collider, and notice it immediately grabbed whatever was in the mesh filter. But we can change this. We can click on the little Load button, and there's our P-Sphere 1 that we used for our teardrop. And now I can assign that as a collider to this object. So they don't have to be one and the same. And this is how, if you went into Maya and made your own custom collision surface, a much more simplified version of whatever it was you were trying to collide, that right there is how you can get that applied. So now, if I was to rotate this over like so and
Make
hit
it a
play,
rigid body.
yeah, and nothing happens. I've done that like so many times tonight, it's really not even funny anymore. So let's go over to Physics, make that a rigid body, hit play, and it wasn't set to convex, which I just talked about a moment ago. So let's make sure that that is set. And then we'll hit play, and boom. So it's obviously not behaving like a box. You can see how that point at the top kind of arrested its rotation. But that is how you can go about using a custom surface as a collision object, even if it's not related to whatever model you happen to be looking at. So again, just as a reminder, mesh colliders are going to be more calculation intensive than your primitive colliders. Whenever you can, use your primitive colliders instead. And I'll actually, in the next video, I'll talk about how you can use several different primitive colliders together on the same object. There is a little bit of a trick to it, and it can save you a lot of a hassle. But that is going to wrap things up for this video. Thank you for watching.